Hey guys, welcome to our 7.9 notes inverse trig. So yesterday we talked about SOHCAHTOA, that the sine of an angle is equal to the opposite over the hypotenuse, the cosine is equal to the adjacent over the hypotenuse, and the tangent is equal to the opposite over adjacent. So using SOHCAHTOA is going to help us solve for the sides of a right triangle. Today we're going to talk about how to find angle measures within a right triangle. And we're going to utilize SOHCAHTOA but in a different way. And what we're going to use are the inverses of these trig functions. So in order to find an angle within a right triangle, we're going to do the inverse sine of the opposite over the hypotenuse. Or, depending on what sides we're given, we can use the inverse cosine of the adjacent over the hypotenuse. Or, last option, inverse tangent of the opposite over adjacent. Now, these inverses, this little -1 means inverse, not raise the negative first exponent. It's not an exponent, it's just a notation for inverse. And remember, all of these inverses are going to help us solve for angles. So you can use any one of these formulas, and the way you get it on your calculator, if we look down at the next one, is by using the inverse sine, inverse cotangent, or cosine buttons. And so the way we do that, for most of the calculators, in the upper left-hand corner, you have a second button. Again, it's in typically the upper left-hand corner. And then if you look lower where you have your sine, cosine, and tangent buttons, written on the calculator above it, usually in a different color, are your inverse buttons. So they'll have inverse sine, inverse cosine, inverse tangent. And so in order to get that inverse, those inverse functions, you have to press the second button first. So in this case, if we were to try to find the value of the inverse sine of 0.62, you would press second and then sine, and then you type in 0.62 and press enter. Now your calculator should be in degrees mode from yesterday, and so when you type that in, hopefully you get 38 degrees. And let's round our answer to the nearest degree, so to the nearest whole number. Okay, go ahead and try B and C, doing inverse tangent of 1.2 and inverse cosine of 5/13. Type those into your calculator and let's see if we get the same angles. Remember, inverse trig will help us solve for angle measures. So the numbers that you're getting are angles, so you should have degree symbols next to them. Okay, so now that we know how to type it into our calculator, let's try the first example. So this first example here wants us to solve the right triangle. When you look at the triangle, notice that we're given 2 out of the 3 sides, 6 and 13, and M, the missing side length, is our hypotenuse. So we could solve for the missing side using strategies from early in their chapter, like geometric mean, Pythagorean theorem, 30, 60, 90, 45, 45, 90. We can solve for side lengths using any of those. Now, for this particular triangle, we know 2 out of the 3 sides, so it would make sense to solve it using Pythagorean theorem. So we'll do 6 squared plus 13 squared equals m squared. So 36 plus 169. That gets us 205 equals m squared. And we will solve using Pythagorean theorem, taking the square root of both sides. I'm going to use the directions from down below where it says round side lengths to the nearest hundredth. So I'm going to use that here. Otherwise, your answer would be the square root of 205, which is approximately 14.32. So we can solve for the missing side lengths using strategies from the beginning of the chapter. And remember, to solve for side lengths, we can do Pythagorean theorem, we can do geometric mean, or we can do our special right triangles. In this case, the Pythagorean theorem worked great. So we are well on our way to solving for finding all the missing parts of this right triangle. The first part was solving the missing side using Pythagorean theorem. The new stuff that we're talking about today is how do we find this missing angle in the triangle. This is the first time that we're solving for the angles, and remember, when we solve for an angle, we need to use inverse trig. So to solve for an angle, we have to use inverse trig. That is our only option. So first thing you want to do is identify the angle that you're trying to solve for, and then you need to label the sides that you're given. So if we're focusing in on angle N, 6 is our opposite side, 13 is our adjacent side. So then we think of which trig function in SOHCAHTOA, which trig function uses opposite and adjacent? Well, that's tangent. So I'm going to set up my inverse trig equation to solve for my angle with tangent. So it's going to be inverse tangent of the opposite over the adjacent. So inverse tangent of 6 over 13. Once I plug in my side lengths and I set up my equation for my angle, now I can just type it into my calculator and get that the inverse tangent of 6 over 13 comes out to be 24.78. And they want us to round, again, I'm looking down below, round the angle measures to the nearest degree again. So this is going to be about 25 degrees. So N, I guess we'll do it this way, N is equal to 25 degrees. So I can put that in my diagram. And we solved for the angle again using inverse trig. Now they could have very well asked us for this angle as well. And I'll call this angle P. What do we know about these two angles, the two acute angles in a right triangle? These two angles should be complementary. So now that we know what N is, could I ask you also what P is? Sure, it would be its complement, meaning they have to add to 90. So it would be 90 minus 25, which is 65 degrees. And so we could solve for those angles using inverse trig and then using that property that we know. Okay, so that's one. Let's go ahead and take a look at these three angles now, or these three triangles, and do the exact same thing. Notice we are finding all of the missing values in each triangle. We're going to round the side lengths to the nearest hundredth, so that's 2 decimal places, and each angle to the nearest degree. So let's take a look at one triangle at a time to solve. So I typically like to solve for the easiest ones first. In this case, I think solving for y using the Pythagorean theorem, since we know 2 out of the 3 sides, would be pretty easy. So to solve for side length, I'm going to use Pythagorean theorem since we have 2 out of the 3 sides. So it's going to be 9 squared plus y squared equals 11 squared. So 81 plus y squared equals 121. Y squared comes out to equal 40. So now I have to take the square root of both sides. Now, since in the directions it says to round my answer, I actually don't want to leave my answer in radical form anymore. Since they want us to round to do 2 decimal places, I can type that in my calculator and get a decimal. So 6.32. 2 decimal places is to the nearest hundredth. So I've solved for y. All right, now we have to solve for the missing angles. Now, we have x and z. It does not matter which one you solve for first. I'll do alphabetical order and solve for x first. Or actually, yeah, we'll solve for x first. So I'm going to focus in on my angle x and then label the sides that they've given me. So I'm not going to use y in this case. I'm going to just focus in on 9 and 11. So if I'm focused on x, 9 is my opposite side, 11 is my hypotenuse. So to solve for angle x, I'm going to use inverse sine, because sine is opposite over hypotenuse. So inverse sine of 9 over 11. I can type this straight into my calculator and get that x is 55 degrees if I round it to the nearest degree. Now I can do the same thing to solve for z. I just have to change my labeling. If I focus in on z, 9 is actually adjacent to z. 11 is still my hypotenuse. So if I want to solve for z, Z is adjacent over hypotenuse, or cosine, so inverse cos of 9 over 11. Type that in my calculator, and I get that Z equals 35 degrees when I round to the nearest degree. At the end, I should just double check, because remember, X and Z should be complementary. So I should check that 55 plus 35 equals 90. They do, so I'm good to go. Okay, so that was one example. What I'd like you guys to do next is, in your groups, try example 2. So if you could pause the video, try example 2, and then come on back and see my work. Okay, go ahead and pause it now. All right, welcome back. Go ahead and fast forward through all of this, and so you guys can just see the answer. And we'll do the same thing for number 3. So just to review, again, I use Pythagorean theorem to solve for A, and then I use inverse trig to solve for the angles. All right, go ahead and pause it, and then fast forward again when you're done with example 3, and we can compare our answers. Again, always make sure, once you're done, to check to make sure that those two acute angles are in fact complementary, that they add to 90. All right, that's it for today. Take a look, take a screenshot of these, or take a look at the answer key on Schoology if you missed anything. But these are the notes for today. Remember, inverse trig helps us solve for angles. Inverse trig helps us solve for angles. So we have that up here. We're going to use the inverse buttons to help us solve for angles. All right, so we're done with notes. Go ahead and get started on your worksheet in your groups and help each other out. Check the answer key, and we'll see you later. All right, guys, see ya.